signals are temperature or current. Digital signals are signals that transfer binary data, on and off, high and low. You can group real-world signals as either analog signals or digital signals. Analog signals are signals that vary continuously and have continuous values. Examples of analog signals are temperature or current. Digital signals are signals that transfer binary data, on and off, high and low. Analog input describes measuring an analog signal and transferring the measurement to a computer for analysis, display, or storage. Let's take a look at some examples of analog input. This analog input example acquires a value from a thermocouple sensor at a relatively slow rate of 2 samples per second. This analog input example acquires a high-frequency voltage signal at a much faster rate of 1,000 samples per second. Other analog input examples include acquiring signals from accelerometer sensors, strain gauge sensors, microphones, current signals, and more. Analog output describes generating analog signals from your computer and NI hardware. Let's take a look at some examples of analog output. This analog output example outputs a voltage ramp to control the speed of a fan. As the voltage increases, the fan speed increases. As the voltage decreases, the fan speed also decreases. Another analog output example would be to output a stimulus signal to a unit under test. For example, you might need to send a sine wave, square wave, or triangle wave with a specific amplitude and frequency to your unit under test to investigate how the unit under test responds. Digital input describes measuring a digital signal and transferring the measurement to a computer for analysis, display, or storage. Let's take a look at some examples of digital input. This digital input example reads the status of a physical button or device. For example, if the digital signal has a low voltage, that can mean that the physical button is not pressed. And if the digital signal has a high voltage, that can mean that the physical button is currently pressed down. This digital input example shows that your application could wait to receive a start trigger from an external digital signal before your application starts a task like acquiring data. This digital input example reads a digital protocol signal where a high voltage represents a binary 1 and a low voltage represents a binary 0. Digital output describes generating digital signals from your computer and NI hardware. Let's take a look at some examples of digital output. This digital output example outputs a digital signal to turn on an LED or another device. This digital output example outputs a trigger signal to trigger another device to do something. And this digital output example generates and sends a digital protocol signal. This course will use mostly analog input measurements for examples. In this section, we will talk about how to set up and connect NI-DAC hardware. First, make sure you install LabVIEW NXG and the NI-DAC MX driver. Then, refer to the user manual for your DAC device for detailed instructions on how to connect your NI-DAC hardware to your computer. For example, I have the CDAC 9178 compact DAC device that contains multiple C-series modules. And I can connect it to my computer using a USB cable. Next, I need to connect my DAC device to the sensors and signals that I want to measure. In LabVIEW NXG, I can find guidance on this by viewing the pinout, manual, and specifications for my DAC device. Let's say I want to figure out how to connect a thermocouple sensor to my NI9213 thermocouple module, and a quarter bridge strain gauge to my NI9236 strain module inside my CDAC 9178 compact DAC chassis. To do this, click on your instrument in the System Designer. Now, I'll click on my 9213 thermocouple module, and now I can view the pinout diagram.